This is Algebra 2 with Trig, lesson 5.2. We're looking at polynomial functions. There's several different. Polynomial functions are a very broad term, kind of like polygon would be a very broad term. Triangles are polygons, squares, quadrilaterals, all those are different types of polygons. Well, here's a polynomial. In a polynomial, you can have a constant, you can have a linear polynomial, a quadratic polynomial. Those we have done in class already. A cubic polynomial, something to the third power. A quartic is a polynomial to the fourth power. So here are some examples of what an equation might look like if it was quartic, if it was cubic, quadratic, linear, and a constant. When we look at a polynomial, there are some characteristics that are going to make it essentially a polynomial or not. So yes, you're a polynomial if you have whole number exponents. If your exponents are whole numbers, not negative exponents. Whole numbers are 0, 1, 2, 3, 4, 5, 6, 7. Those are your whole numbers. Fractions as coefficients. You can have fractions in front of your x's. You can't have fractions as the exponent. Things that are not polynomials. Fractional exponents, or even decimals for exponents. That's going to limit what the values of x can actually be. We'll talk about that more in the future. No variable in the denominator, because there would be a limitation to what x could be. You can't have 0 in the denominator. So if you have a variable in the denominator, most likely it's possible that that equation, whatever in the denominator, could become a 0. The exponent itself can't be a variable. If the exponent is a variable, then it would not be a polynomial. So we first need to decide if our given expression is a polynomial. If so, we're going to write it in standard form. We're going to talk about the degree and the type and the leading coefficient. Okay, so we look at this part A. It's listed from largest exponent to the smallest. There's no fractions with denominators with variables, but this does have a decimal for an exponent. So is it a polynomial? The answer is no. 4 to the x to the 2.5 power. You have a fraction, or a decimal as an exponent. That actually limits what x can really be. We'll talk about that in the future. Okay, we look here. We notice that the exponents are not in descending order. We do have a decimal, but it's an coefficient, and that's okay. So if we rewrite this with your largest exponent first, then your second largest. So our exponents are 4, 2, and 1. So yes, this is a polynomial. The degree is 4. The type is quartic because it's to the 4th power. And the leading coefficient, of course, is 9. It's a positive 9. So we look at our exponents. We notice here that we have a negative exponent. So no, this is not a polynomial. The negative exponent implies that the x would be in the denominator. So there's a limitation to what x could be. The graph would not be a consistent graph working from the left all the way through the right. There would be a number that it couldn't equal. What do we think about letter D? Is this a polynomial? It's okay to have 0.6 as a coefficient, but you can't have a variable as an exponent. Letter E. 7x to the 1st power, that's okay. The square root of a number by itself is okay. Pi is okay as long as it's not the exponent. X to the 3rd is okay. So this turns out to be y equals your largest exponent is 3, so that would go first, and then 1, and then no variable. So that would be standard form. The degree is 3. The type is cubic, and the leading coefficient in this case happens to be pi, which is 3.14. What do you think about F? Is that a polynomial? It's okay to have 7x would be fine. 4x to the 4th is okay. 3 by itself would be fine, but you can't divide by a variable. That limits what x can really be. X could not be 0 for this whole function. if you plug this equation into your graphing calculator, you would see that x equals 0, the graph wouldn't exist. Looking at the table, you'll see an error. So, the answer is no, this is not a polynomial. Okay, when you have a variable in the denominator, that's the same thing as having a negative exponent. They're the exact same thing. So my argument here is that it has a negative exponent, or you could just say that it has a variable in the denominator. Is this a polynomial? We see that it's x to the fourth, x squared, x to the nothing. It does have a fraction, but the fraction is a coefficient. That's okay. So here we would say yes. It's already in standard form. So the degree is 4. The type is quartic, because it's to the fourth power. And the leading coefficient, the coefficient of the largest exponent, is 1. What do we see here? Is this a polynomial? And if you look, 3/4 x is okay. Negative 7x cubed is okay, but you can't take the square root of x and make it a polynomial. There are limitations to what x can be. X can't be negative. So x, the square root of x, is really a fractional exponent. You can say that it has a fractional exponent, or you can say that you can't take the square root of a variable. It's not that this function doesn't exist. It is actually a function. It's just not a polynomial function. Next, we're going to talk about substitution. When we substitute, here we're looking at x equals 3. We want to know where this function is when x is 3. So using function notation, we say f of 3, and it's good to write out your equation. When the x value is 3, that means we're going to plug a 3 in for every x. This is not 6 to the 4th power. This is 3 to the 4th power. Not 15, but just 3 to the 3rd power. f of 3 would be 23. Just normal substitution like you always have for many years now. Let's try substitution with a negative. Notice how I'm putting the negative 2 in parentheses. We should write that in function notation. So negative 2 to the 4th power, 16. This is not negative 4 to the 3rd power. Many people make that mistake. Two to the 3rd power is 8. Negative 2 to the 3rd power is negative 8. So when we plug in a negative 2 into our function, we get a value of 5. This is called direct substitution. You've done it many times in the past. Next, we're going to look at a process called synthetic substitution. This is a method you're going to need to know how to do. It is quicker, it is faster, it takes up less work. It'll give you the same results as we would have in direct substitution, but synthetic substitution honestly makes it smoother. It's very important to put our numbers, our actual function, in standard form, which means your largest exponents first and you go down in descending order. We're going to look at the coefficients. We have negative 3, 1, negative 12, and negative 5. So all you have to do is take the numbers that are in front of each of the x's. And here we would call that x to the 0 power, so we still include the negative 5. If one of the x's wasn't represented, one of the exponents in descending order was not represented, you have to represent that with a 0. We put a bar underneath, and that just helps us with organization. If x equals 2, we know what x is supposed to be. We're going to substitute the 2 into the equation. We're going to put the 2 on the outside. Now we're going to take each of our numbers. We're going to take the negative 3, add it to nothing, which makes negative 3. So essentially you bring it down because there's never anything there. Then we're going to take the 2 and the negative 3. We multiply those together to get negative 6. We add the 1 and the negative 6 to get negative 5. Multiply the 2 with the negative 5. Add them together. Multiply the 2 and the negative 22. Add those together. So we know that f of 2 is going to equal negative 49. That's the same thing you would get if you plugged in 2 into your equation and did it your typical direct substitution. Notice there's a lot less to write, lot less numbers to worry about. Their special multiples into the third, fourth, fifth power sometimes. A lot easier to calculate this. Let's try it again. What seems tricky about this one? It has x to the fourth power, which isn't going to change much, x to the third power, x to the second power. Notice how it does not have x to the first power in it. We look at our coefficients. So x to the fourth power has a 1, third power has a 2, second power has a 3. X to the first power doesn't exist, so we have to put a 0 to represent that. X to the 0 power is a -7. Those are the coefficients for each of those types of x's. Place in the bar. You know that you're going to be substituting in x equals -2. So now what do we do? You take your 1, you bring it down. -2 times 1. Add those two together. -2 times 0. Add those two together. -6. Add those two together. -2 times -6 is a +12. Add those two together. So we know that f of -2 is going to equal 5. You can look at more examples of this in example 3 on page 388 of our textbook.